Okay, so welcome to lesson 3B on what results to present in your detailed LCA report for your EPD. So I'm going to turn to the report template that I gave you and turn to the environmental life cycle impact assessment section. So we're going to focus, I recommend using Tracy 2.1 for your results and to focus on these 5 impact categories, because this is the most common impact methodology used in North America. I'll show you a PCR that's been used for it's basically the go-to PCR for concrete in North America. And this is what they recommend for their impact categories to include. So they have the 5 midpoint categories that I have in the tables already in the template. So you don't really have to do much there, but you're welcome to to edit or change this however you see fit. You can find more information about Tracy if you just Google Tracy and EPA, you're going to find this link where you can download the manual to get more information about it. So you're always welcome to change this. But yeah, and if we look at what else is included, they have a number of life cycle inventory data that represents not only like key life cycle metrics, but also metrics to do specifically with concrete. So obviously those aren't really of interest. So for the template, you can see that what we have included is the following metrics. And so what I recommend is adding a third column just to say what impact methodology you use to get those metrics. So you can use cumulative energy demand to get the energy related metrics. And then for non-renewable material resources, I recommend using the recipe midpoint methodology for mineral resource depletion. And you can also use recipe for water, because it basically tallies up all the water consumption. As for renewable material resources, this I'm going to sort of leave open because it's a little bit in a way subjective. Like if your product clearly uses a renewable material resource, then I would include it to the best of your ability in terms of understanding how much is being used. Otherwise, you can always turn to the Excel results output, the quick results or the other one, and you can look at the inventory to look up to see if there's any particular renewable resources of interest. There's not really a lot here per se. A lot of it is non-renewable, but like for example, wood would be a renewable resource, so you could include that. So let's turn to openLCA, and I'll show you. So I'm going with the same example of steel, and if I go calculate, I can choose this recipe method. So it's midpoint hierarchical to get the resource and the water indicators. And then for the energy indicators, you can use cumulative energy demand. So I ran those results already. And so for cumulative energy demand, the categories that are provided to you are the following 6. And so there's 3 non-renewables and 3 renewables. And it can be nice, well, we'll get into the results presentation, but to show a breakdown of each one, just in terms of total is fine. And then when it comes to recipe, the mineral resource scarcity will be the one you'll use for this one. And then for total water consumption is just the one that says water consumption here, which tallies up all the life cycle water requirements in your system. So let's move on now to the results presentation. So I know I've been saying earlier that you should break your results in terms of A1, A2, A3, but this is really more focused on construction systems. So if I turn to the PCR I just showed you, you can see this is what you're already familiar with as well, is the different stages in a building LCA, and for the initial focus or criteria was a construction product, but I was a little bit open. So maybe you don't have a construction product, but the general focus is from cradle to gate, and that's considered in A1, A2, A3. So what I sort of made as a minimum criteria is give a breakdown between A1, A2, and A3, but that's not necessarily the most trivial thing to do, especially when you're relying a lot on market mix processes from EcoInvent that have transport embedded into all these inputs that are coming directly from the background database. And so it would take a lot of effort to like tease away what inputs are due to transport directly to your core process or your A3 process. So I'm not going to necessarily require you to do that, but if you can, it's more than welcome to show that breakdown. And actually, you'll also notice if you read the construction PCR that it's not actually a requirement to show that breakdown between A1, A2, A3. It's just recommended. But I do expect you to show some interesting breakdown nevertheless. But you're welcome. Is sort of, I'm going to keep it a little bit open, but I'll give some recommendations. So for this section, I recommend showing total impacts for all the categories. Now you can show it in a graph with labeled values, for example. At the very least, show a table, but graphs are always, make the report look a lot nicer. Just be sure that at least that the values are presented. Like I don't only want to see graphs with no values, because then the reader is unable to know what the total values are. But going beyond just showing the total values, I want to see some interesting, say, hotspots or contribution analysis in some other form. So what you could do is, if you look at openLCA and we go to our detailed analysis results and we go to impact analysis, well, now we can see the total, but remember we have n top contributing processes for every single category of interest. So our categories of interest are smog, acidification, and eutrophication, global warming, ozone depletion, and yes, so that's 1, 2, 3, 4, 5. So those are the ones that we want to present on, and you don't necessarily have to use 10 as a criteria. You could also stipulate in your report that you're taking a 1% cutoff criteria. 1% being the activity has to contribute at least 1% to the total impact in order for it to be displayed, or you could say it could be like two conditions, either 1% or top 10. And so what you can do then is select the top row of interest and just copy it into your Excel. So if I right click and press copy, then we can go over to an Excel book and copy it in. So now we have the information we want. It's still a little bit, not looking very nice. You should clean it up a little bit. For example, we don't really need to include this in between information, and some of these activity names are quite long. So if you're going to present it in the report, I would tidy it up a bit, take some of this out. It's quite repetitive for some parts of it, so just sort of reword it into a nicer way. And yeah, don't necessarily include the whole list, but you could include like, for example, the top 10 would be this many, and then you could include other. So from this table I would create a cleaner table, and you could also include the relative, so have the absolute, but then also have the relative contribution here. And then you also don't really need to have this row here. You can bring it into you can label the column based on, and put the units there, and then have each impact category in a nicer table where it's impact 1, 2, 3, 4, 5, and you can show that for Tracy, and then you can also show that for the other metrics if you like. At least do it for Tracy. You can do it for the other ones too, but I do recommend like a top N contributing plus the other So yeah, the way you'd get the other is simply taking the total and subtracting it from the top 10. And that there's, so that if the top 10 is about 0.055, well then all the rest of the activities in the system would just be the total minus 0.055, and that will look like a very nice table. What else can you do then? So for so yeah, like I said, try to do that for the Tracy categories. Now you can break this into subsections, so you can have it in terms of Tracy midpoint categories, and then the next subsection could be key lifecycle inventory metrics, and that would cover these ones. And you can do the same sort of top end contributing processes if you like, or in terms of the total, it would be nice to show at least a breakdown for the cumulative energy demands in terms of the 6 categories, because that's sort of a nice and easy way of showing the results, because in this case everything's in megajoules, so it's okay to combine it, whereas these categories are not in the same category, so you can't add them together, because it's like adding apples with oranges. You want to keep them separate. But since these are the same, since these categories are the same for, let's just go to it here. It's all in terms of megajoules, right? So it's okay to combine it into a single graph, into like a stacked bar graph or a pie chart. And then you can show the breakdown in terms of the total cumulative energy demand across these 6 categories. Of course, you can write them in a nicer way, and not to include this as well, because it's too big of a label. But yeah, you can certainly go ahead and do that. Okay, so if we go back to the report, in terms of this used to say sensitivity analysis, but I don't really expect you to do a sensitivity analysis yet. It's recommended, but it's better if you have actual original information data from the client. But you could run an uncertainty analysis, and I've shown you how to do that. You can run it quite quickly. Well, I shouldn't say quickly, but you can set it up quickly. It takes some time, right, as you know, depending on how your computer is. But I do recommend that you do at least 1,000 iterations, and that can take a long time for some computers, but you can run it overnight, for example, and you'll get your iterations out. Anything less wouldn't make sense, and I don't expect you to do it for all the categories that you require, like the cumulative energy demand, Tracy and recipe, but I would just do it for Tracy, for the main categories, and then you could run it and then export it into Excel, and then you can you can look up ways of graphing it, or showing it statistically in tables, showing the various percentiles, for example, would be a nice way to show the results. In terms of making a histogram, that could be nice, and that can be done in Excel as well. There's plenty of resources on the internet you can look up on how to make a histogram. I didn't really have this as like a major criteria initially, so if you do manage to create some uncertainty results, I will give up to 5% like bonus for doing that. Now in terms of interpretation, so you're going to basically present and explain your results with top 10 categories here, and then interpretation will get more in greater detail of every single impact category. So having like subsections for each category, 1 to 2 paragraphs for each one, just going into like where are the major hotspots and what are the major reasons. And so of course you have your top 10 results, which tells you quickly what are the major activities, and you can see, like, also you can click on the given activity to see what are the major contributors, just to have a good understanding of why those impacts are occurring. And you can explain all these things for each category, just focusing on key processes in the value chain, like sinter productions, mostly due to nitrogen oxides, 100% due to it. And then what you can do is also consider the results on the contribution tree, because that tells you more about why the impacts are occurring, whereas the other one was just showing top N activities, but you didn't really know the connectivity of why it was occurring. But this contribution tree will give you a better sense of that, and you can actually create a nice like contribution diagram using the results from here. So you just have to be mindful that it doesn't add up. There's a certain cutoff criteria, so it doesn't add up to 100%. If you added that up, it was, I think when we looked at it, it was about 96%. And so you'd have to include another category of other. So you could even show results just at this first tier of contribution. But since we know our major value chain in this case was, were those processes that we created, sinter production of iron, sinter iron, iron ore beneficiation, and iron mine operation, it'd be nicer to see the breakdown in terms of these key processes in your system. And it's possible to do that. You just have to be careful because, like I said, it doesn't always add up exactly to 100% depending on where you are. So like here it wasn't to 100%, and then the 75%, if you were to add up everything here, you'd get it wouldn't be 75%, but of course you have the direct impact at pig iron production too. And the direct impact here, of course, you can find it if you look up impact analysis and you go, you have your top N contributing processes. So here's pig iron. So this is the direct impact, 0.764. So if you go back here, then you know that the direct is 0.764, whereas the rest is indirect or upstream of it. So if you take 0.764 and then you add it to the rest of the numbers here, you have to ask yourself whether that adds up to 1.47. And if it doesn't, that means there's a certain cutoff that it's not including certain things. So you'd have to put other, for example. And so I guess my point is that you can bring this out into Excel and work out that contribution breakdown, and you just have to be careful with that adding up to make sure it adds up to the total. And wherever it doesn't, you just have to include an other, and then at the end you can sum up all the other from each level of the tiers, right? And that can be a nice way to show like 100% or an absolute breakdown of key processes in your value chain. It can be achieved through a combination of this breakdown and knowing the total of key impact categories, or sorry, key activities in your system. Okay, so that's about it. You can get into a little bit of study limitations. What that focuses on is mostly where you could make the most impactful improvements, and that's more related to when you see the greatest hotspots and you understand why it's occurring, then you'd have to ask yourself, what's the quality of that data and what could you do to make it better? Because that's where you want to ensure the highest quality of data is where the biggest impacts are occurring. And then the references, I recommend including some references. For example, a reference to the product company website, a reference to the PCR that you're using, a reference to the program operator website, and any other references. You can, when you look at EPDs that are out there, you can see they have maybe half a dozen or less references, so they don't have too many, but it's important to include a few. And actually, when you're creating your EPD report, which is a distillation of this detailed report, you would reference this detailed report in that EPD report too. That would be recommended. And for appendices, we can always include appendices with further information and data and results, but it's not a requirement for the course project. But you're more than welcome to include some appendices that relate specifically to particular information of your system or your product. It could be like product information, or some further technical specs, or more detailed results. So that concludes part 3B on a brief overview of what to include in terms of results in your EPD course project.